Now we're going to do an application of an infinite series, an infinite geometric series. So we're going to be using this formula in a second. And in both of these examples, what we're going to do is learn how to turn a repeating decimal into a fraction. So the first one, notice that the 4/5 is what repeats. So this is really 2.8 plus 0.045 plus 0.00045 plus so on and so forth. Notice we have gaps for the 0 because the eighth here took up the tens place, and the 0.45 took up these three places. That's why we have the placeholder of the zeros going on there. Notice that the geometric part does not include the 2.8. It's the 4/5s that keep repeating. So when we're going to use this formula at the top, this 2.8 just sticks around. Notice the first term of the geometric series is 0.045. So that'll be our a sub 1 over 1 minus. Well, to figure out what r is, remember you can take the next term of a geometric series and divide by the previous term. Doing so, we'll get 1/100th, so 0.01. And now we clean this up, so a little bit of arithmetic here. So we'll have 2.8 plus 0.045 over 0.99. If you should recall, if we move the decimal up top of a fraction 3 over to the right, we also have to move the bottom 3 over to the right. So this should be 2.8 plus 45 over 990. 2.8 is 28 over 10. 45 over 990 is a number. .45 goes in 990 22 times. So 28 tenths plus 1 22nd. Let's see. We would need a common denominator here. Oh, we could reduce the first one. We could say 14 fifths plus 1 22nd. Oh, that's okay. So now we'll multiply this one by 22, top and bottom. This one by 5. So 22 times 14 plus 5 more makes 303. And 22 times 5 makes 110. I'm sorry, 313. And then 110. And you can check your answer in your calculator by doing 313 divided by 110. And you get 2.845454545. The second one, you may already know the answer, so don't root it. 0.9 repeating is 0.9 plus 0.09 plus 0.009 plus ... So unlike the previous one, we don't have anything hanging off the side like our 2.8. Everything here is repeating. So our first term of our geometric series would be a sub 1 would be 0.9. Our common ratio, what do we keep multiplying by to get the next number? Yep, we multiply it by 0.1. So we'll have s sub infinity is a sub 1, 0.9, over 1 minus r, 1 minus 0.1. We'll notice that's 0.9 over 0.9. What is 0.9 over 0.9? 1. Fancy. So 0.9 repeating is 1. There's actually a couple of proofs for showing 0.9 repeating is equal to 1. This happens to be one of them. You could also show it using a system of equations.